pushing to stop this reminiscence.
Hello and welcome to another episode of Cambridge 02139. Tonight I have the pleasure to be here with Luis Bettencourt. Luis Bettencourt is a research scientist at Los Alamos National Laboratory and the Santa Fe Institute, and among all these affiliations, Luis finds time to work in a lot of different things. One of the things that you have been working with your colleagues is to try to understand cities and to try to make a science out of cities. So what do you mean by a science of cities? What is the aspect of cities that you are trying to understand?
Well, I was very interested in just trying to understand people. Actually, my background was in theoretical physics. For quite a few years, I spent time understanding fundamental theories of matter and radiation. But I understood at some point that my heart really was with trying to understand all this. Basically, how is it that people come together and create cities, human societies? Where do new things come from? And at that time, I just started wondering, how is it that the things I knew how to do in science, that I had been trained for, could map onto sort of a more quantitative, predictive understanding of human societies. At the same time, I have to say that sort of at a personal level, nothing would give me more joy than just take a plane ticket somewhere to a city I didn't know and just try to figure it out, to understand, how it worked, where the good restaurants were the cool places to be, where was the art, etc. So, if you do that exercise, you get sort of an intuition that I think we all have, that there's something universal about cities. That universality is more about how they're organized, what people do when they're together, and what kind of things spring up as a city gets larger and larger. And so I wanted to try to understand what it is in some predictive, quantitative way. And so that ended up happening through a series of accidents. So I was here as a postdoc. I went back to Los Alamos, and I came to the Santa Fe Institute, where there was a meeting about social organizations, and several of us kind of started fidgeting in the back, including my friend and colleague Jose Lobo, about why don't you measure it? Why don't you build a model for it? So we started doing that. And to our surprise, that came a little bit in the context of what you heard before from Jeffrey West, where there was an expectation of maybe certain scalings of complex systems with size, namely they become more efficient, energetically maybe they'd slow down. And the intuition was coming from something that maybe we'll talk more later about how science and technology and other forms of human creativity get expressed. All those things seem to accelerate, and you seem to get more as you put larger systems together. It's a phenomenon that's very curious, that I think it's poorly understood and it's poorly known, but the anthropologist Robert Carnero actually called it quality from quantity, which is sort of the opposite of what you'd expect in physics, where you tend to have the idea that you put a larger system together and perhaps it will tend to more perfect randomness. In complex systems, often what you get is the opposite, is that as you put a larger system together, it tends to, some parts may specialize, become interdependent, and you end up with more functionality. And so that became sort of a central theme of the things I was interested in. And cities, I think, give you sort of one of the ultimate and at the same time quite tangible places where you can start studying that. So we started looking at lots of data that we could get our hands on, and seeing how these depended on size, on density, and perhaps other measures. So there was this idea that there were measures of extensivity of the size of the system, like population or area. And then there were also qualities of the system, like how rich it was, how creative it was somehow, if you could measure that. And we started seeing these relationships that were just very predictable. And that told you that, now we say it in sort of a cleaned up way, that basically when you double the size of a city, you tend to have the increase in all these social economic quantities, including things that are sort of the essence of why human societies work, namely economic productivity, so money-related quantities, but also any measure of creativity, of functionality, they tend to multiply as the system gets larger. And so the question starts then to become why, and what's sort of the mechanism that underlies that.
And when you say they multiply through like some special non-trivial sort of function, or? So
we know sort of what the mechanism is qualitatively, and you yourself have looked at it from a slightly different angle, but it's essentially with the same ingredients. So a complex system needs to be able to use energy and do things with it, at least to keep those units going, but also interestingly in human societies, in biology as a whole as well. But in human societies, it's very obvious that you create economic value and new cultural forms that basically keep people together. and keep people wanting to interact with each other, both because they're interdependent, but because I think fundamentally they enjoy it. And this also has a negative side. So crime tends to scale up, the numbers scale up in the same way, for example, as economic productivity, as do measures of creativity. But these measures then are telling you that a city really is an interacting system of people and then of organizations of people like companies and so forth. And these exist because they support each other in some form that tends to bring them together. So it's known to sociologists, for example, that left to their own devices, people like to separate. They like to live with people just like them. It may not be true of everybody, but it's true
The
on
homophily
average.
idea.
Yeah, exactly.
Birds of a,
that we see,
birds of a
exactly,
feather
we see
flock
this a lot
together,
in
and
social
lots of
networks, and we see this in lots of
Exactly.
places. So if the world was simple, that's what would happen. And in fact, I mentioned sort of anthropology before, but there's this idea again that small tribes are very stable, so of order, 100, 150, maybe 200 people. But it's very hard to grow larger because it takes a new organizational structure. It takes getting new forms of existing together that will allow you to grow larger and still, not kill each other. And so that sort of thing needs to develop with size. And so size is not so much the cause as it is sort of a sign that something was developed that allows a larger system to stay together. And what's interesting about cities is that they seem to exist in this continuum where new things get invented systematically, both in terms of infrastructure, of conflict resolution, of innovation, of the creation of economic value, that allows them to go along and become larger and larger. And when you look at the distribution of sizes in a city, in a country of different cities, or if you look at their economic productivity, they're in a continuum where this continuum is expressing cities of larger size, but also cities where things happen with larger variety and faster. So there's sort of an acceleration of social life, including the creative aspects of social life.
So is the colloquial observation that people walk faster in New York City than in Topeka, Kansas?
That's exactly right. So basically, when you double the size of a city, people walk faster, if they have to walk, which usually they do in larger cities because it's possible because they're denser. So that's exactly right. There's not only sort of an abstract intellectual feeling of more things to do and less time and larger value of money that pervades everything. There's also an actual physical sense of that that's expressed, for example, in how fast people walk.
And when it comes to the idea, for example, of sustainability, so how do cities compare to urban sprawls? Are they preferred? Are they non-preferred? What's the verdict there, or at least, the evidence that you have so far?
So that's one of the great questions of sort of when we look at policy and development of human societies, not only from the economic point of view where, economic development is desirable, but also when you look at its consequences that often are not measured economically. So a city exists always in this tension. So before you even consider its ecological impact, the largest city in any urban system, and this is true especially when you start looking at history, has always existed at the brink of possibility. So when you look at New York 100 years ago, or London 150 years ago, or when you look at the mega cities of the developing world today, those cities are just on the brink of being unbearable because they lack a certain level of organization, because there are a lot of people that live at the threshold of existence, and so because they're often violent. So there's a sense in which solving the problems of these very large, very challenged places, and those problems are then solved typically through better infrastructure, more efficient infrastructure that's made possible because people live at greater densities, is actually the key to living more efficiently in terms of infrastructure, in terms of energy delivery, and so forth. And this is so true that now that we start measuring, for example, the carbon impact, the carbon emissions impact of different cities and different urban systems around the world, you just see this. Larger cities actually consume less energy per capita and therefore emit, in the present technology, less carbon than smaller places. And this is for a variety of reasons. Most of them have to do with the way people live. So you tend to live more densely in apartment blocks instead of large houses that have a lot of surface that can lose a lot of heat. But also because you can walk. So if you look at actually the energy budget of how do we all spend energy in different components of our lives, you will find that most of the energy you spend is, for example, driving, if you drive, or in heating your house. So all these things are made more efficient, at least the possibility is there, as places get denser and get larger. So this is why a larger city, though it doesn't look so green, actually leads to a smaller energetic footprint of on a per capita basis. At the same time, you have the other part that's equally interesting, perhaps even more so, which is the type of economic activity that happen in cities. It's not always true. It's not true of China today, but it's true of the US. Tend to be less energy intensive as well. So they tend to be more knowledge based, more having to do today in most developed countries with media, with the arts, with sciences, etc. So these are the things that we actually, economically value most, because these things actually are the ones that command the greatest prices on our time. But at the same time, they're less energy intensive in many ways. So that's one aspect of it. There's also the aspect that cities are self-regulating in a certain sense, because it's not all good in the sense that economic productivity also determines the prices of things in the city, like housing, like energy, like many other things. And so what happens is that a city, as it grows larger, also becomes, imposes certain selection effects on people, in that it's difficult to consume a lot in terms of both quantity and in terms of the prices of things. It's also hard to have space for those things because space is so expensive. And often urbanization is also connected in ways that, still need to be understood better, but they're obvious, with a growth in population growth, because basically growth, it happens through the usual demographic transition mechanism that death rates go down, because in principle, not always, but in principle, as cities get better organized, healthcare, access to healthcare is better, and water, and sanitation become better. But then also that leads, because it's expensive and selective, to a decrease in birth rates. And so you see that countries that urbanize also tends to regulate their population. So these are all ingredients that, although cities by themselves can continue to grow because they continue to invent new ways of creating economic, cultural value, which at face value seem to be negative things from the point of view of sustainability. At the same time, they're self-regulating, and they lead effectively to smaller ecological footprints, at least they can, as they develop. So there's sort of two faces of urbanization. They're very interesting, that live in tension, and that are a great place to study and to understand better.
In a city, you don't get only more of the same, but you get different things, and as you say, you also get a lot of the good things, but a little bit also a lot of the bad things, like crime and whatnot. I know that you have been interested in understanding science and technology and sort of like the macro structure of science. And in a recent paper, you looked at, like, if I remember correctly, like 1 billion interactions between users and content in scientific websites. So tell me a little bit, what was that project about?
So that was a project that was actually led by a colleague of mine, Johan Bolen, who was then at Los Alamos. It's now at Indiana University. And the idea of the project, is funded by the Mellon Foundation, was to think about sort of faster ways of measuring the development of science, but more to the point, scientific impact. So science and technology is sort of interesting because, probably one of the challenges of justifying the investments that nations and corporations, for that matter, make on science and technology is to see their results. Usually, of course, as scientists, we tend to value a work based on how many other scientists use it. But it turns out, actually, that's kind of a sort of internal measure of success, right?
Baseball.
Exactly. It's okay, but it's still sort of our people, right, looking at it. So, you
can have an echo chamber sometimes.
Exactly. You can have fields that kind of, are self-sustaining. And, there's probably ultimately nothing too wrong with that, but probably it's not what was designed to be. And so part of the idea was to see how science is used and is accessed. So the idea of this process is to look at just clicks, how people come and look at the paper and download this paper. And so the idea was to look then, it was to hook up with digital libraries and with publishers that have access to this sort of data, and to start seeing how people surf, the web of knowledge, so to speak, to borrow
so there was the web of knowledge
term.
itself, or was it
another website? It was the web of knowledge in some cases. But so there are several ways in which you can measure this. So this is the wonderful thing about technology, right? Is that we've all dreamt of understanding and just peering at human behavior, social behavior, But now we're starting to have the tools to do that in some way. So through the web, you either can look at what people do as they go out of your institution. So probably MIT libraries might have a link resolver that allows them to see what you do as you go to their library system. But also publishers can see as you come in.
Exactly.
So if you go to Elsevier or any other publisher, they can see that. Or if you stay in Web of Knowledge or Web of Science, they will also see that. So the different kinds of data of that sort. But then, you just get this idea of what does somebody read and what do they read next and what they read after that, how long they take with each document and so forth. And people had looked at this sort of thing for advertisement, early on. Bernardo Huberman and others had looked at, Yahoo websites and others. But the question is, you have this idea that perhaps scientific or scholarly access is a little different. And so we started to look at that. And from that, we could see that people actually read much more omnivorously than you'd expect if you just imagine that they read in their field. So it's very interesting because there seems to be, two aspects to that. One is that, yes, papers that have a large exposure and that a lot of people click in seem to be cited later also more. So comparatively, this is not a bad predictor of the ultimate impact of the paper. But more to the point, what you don't see in the citation patterns is that when you end up citing is a pretty high bar measure.
Exactly, the paper has to be accepted and,
yeah, and you don't cite everybody, and you might
Yeah.
cite also for reasons, of course.
That may be political. Who
Exactly,
knows?
you said it. And so the question then became, how is it that people acquire knowledge? Perhaps that was the question I was interested in. And so what you see is that they read all over the place, but they don't cite that work. So you end up with a network that, for example, integrates much more the natural and social sciences than you might have expected. And so there are aspects to that we're just starting to unveil that have to do with
So in a
this.
way there is impact that escapes citations.
Yeah.
And that they're works that could be well known, yet they're not that much cited.
Exactly. And you see, I think we're starting to all experience that when we work particularly in this field of trying to understand social dynamics, which is very tangible to a lot of people, but not only to our colleagues that sort of do technical work in the field, but to people out there who are thinking about these same questions. And you just start seeing that, my issue always was that I wanted to have a measure of the social and hopefully also economic impact. After all, what is science and technology? You're creating things that might have economic value, yes, but you also care about something that has cultural value. Probably, general relativity has had tremendous scientific impact and tremendous cultural impact, but probably not a lot of technological impact. So I think as science progresses, there's a lot of things like this, that you see that some work has really tremendous cultural impact. And this is actually something that's been very hard to quantify. And as agencies move more and more towards hard metrics, it is something that I don't want to see totally disappear. And I think now we have increasingly the means to measure that. At the same time, I was just very interested in how fields form, how people communicate and collaborate or not, and how sort of the social dimension of the work in a field actually defines it much more than sometimes the conceptual dimension of it, and how these two things come together. So in another work with a colleague here, actually, David Kaiser at MIT, we've been looking at when you follow a field actually, there's this magic. When you look at science and technology, almost everything seems to grow exponentially or faster than exponential. We know this is not sustainable, but for a while, for successful fields, this happens. And it happens in very curious ways. Like, for example, half the people in a field only publish in a single year. So there's an amazing revolving door phenomenon that's creating this. And at the same time, what you see is that when a field forms, so you can pick any field that, network science, you can pick, carbon nanotubes, nanotechnology, sustainability science, all these fields as they grow, they create a conceptual unification that you see in collaboration. Fields basically percolate in our lingo. And this happens more or less at a time when you get the feeling that there's a concept or a technique, if it's an experimental field, that becomes unified. But this doesn't happen for unsuccessful fields, like cold fusion, for example, where there was, people thought at some point they had an experiment or a concept that would work. But turns out you have, hundreds of papers in this field, but no one collaborates with each other. There are all these clusters that don't. So you start to see that the social dimension of how people work and how they share information actually has a lot to do with the maturity and the development of a field. And so these are some of the things I enjoy trying to explore and try to understand, because they're the enabling factors, just like in cities, as we were discussing before, of what makes these social systems greater than sort of our individual capabilities.
So you're not from Los Alamos originally. Where are you from?
I'm from Portugal. I was born in Lisbon, and I think that sort of informed a little bit, the person that I am, and ultimately also the science that I do. So I grew up there in the 70s, and you have to imagine that in 74 in Portugal, as in Spain and Greece, this is a time of great change in many places, but this is really a time where there was dictatorship before that, there was a change then for, Western democracy, and there was a time in my parents' generation of enormous hope and change and construction of something new in a sort of disorganized, messy way full of mustaches and sideburns and things like that. And, and that was what I sort of remember growing up in. And I was fascinated by that enthusiasm and that energy in the air, and at the same time by the fact that as time went by, there was a lot of hope, but there was little tangible change.
Okay.
And I wanted things to be better somehow, to be, yes, interesting, but also, for economic development and for some of the poverty that you'd see back then to improve and so forth. And so I think that there was sort of, and my parents were sort of on the left and sort of had that idealism. And so that was part of what I became interested as a person. And then at the same time, I was very interested in theoretical physics because I saw it sort of as the ultimate, part of science, that you could understand everything all the way to the Big Bang and understand how the universe had come to be and understand the fundamental forces of things. But I guess even then, as I was studying that, and I enjoyed it thoroughly, and I think it's one of the best educations in science, I think I was still trying to find how do you put the world back together. And putting the world back together is what this business of complexity in some sense is trying to understand how, if you understand the world at some level of resolution, and in physics it's kind of curious, right? Because ultimately, after all that history in physics, you learn that the elementary parts of the world are more or less simple, at least to simplify things. But of course they create all this complication when they get put together in terms of materials, in terms of atmospheres, planets, etc. But then when you start thinking about people, it's almost the opposite. I know that there's a lot of interest, for example, in agent-based models. A lot of microeconomics is based on positing certain behaviors for people, and then hope the aggregate behaviors come up. But sort of I see it as a little different. I think people are very hard to predict on an individual basis. But I always joke that sort of casinos and insurance companies make a lot of money. So that's not by accident. It's that people sort of, as they come together, they aggregate to predictable things.
So the laws exist on the aggregate, but not exactly at the individual level.
Exactly. And that's also the history of much successful science, theory of evolution or the macroscopic laws of physics were discovered first. Exactly. Yeah. And then people understood that has some expression that we don't understand in detail in complicated materials, but we understand in simple materials that may aggregate to those laws. But in some sense, I think my gut feeling, and I think it's sort of justifiable, is that human societies have a little bit that character that somehow will become more predictable, though still complicated on the aggregates, but individuals are complicated. So it's very interesting to come from that point of view, that more macroscopic point of view, and try to understand what makes then a city tick, or what makes science and technology
then
possible.
That led you to study physics in Portugal?
Yes.
Yeah?
So I studied physics in Portugal, and then I didn't want to come to the United States because it seemed like a bit of an alien society to me at the time. And so I went to England, and I studied at Imperial College, did my PhD in theoretical physics, and then I got an offer position in Germany, at Heidelberg, for a postdoc, and my girlfriend at the time, we went, but she hated it there. So I needed a job fast in an English-speaking country,
okay.
And Los Alamos came up. And I had come and visited and given talks in the US, but then, what was clear to me at that point is that science in the United States, this is a bit of a generalization, it's not true of every place, either in the United States or outside the United States, but I felt that in general, in a good place in the United States, science tends to be very exciting. People are excited about it, it's very international, and there's a sense of pursuing something that you're passionate about and that you want to crack. And that's not always true. I think in Europe, there are places where that's possible, but it's still a little different.
There's something special about doing science in America, you say?
Science is ultimately an intellectual endeavor that's universal. And so I think if you have the places where it's possible to put people together that are passionate about what they do are always better. And I think a lot of places in the United States, like MIT, like Los Alamos at its best, like certainly the Santa Fe Institute, have that character. And so it's possible to, start with an idea and pursue it and see where it goes, so you can escape a little bit the trappings.
And, if you go to an encyclopedia and you open the biography of any person, you would say, well, like the first thing that you say is like you have the name, okay, you have like the date of birth, you have the city, you have the date of death and the city, and then you see, well, all of these guys made it to the encyclopedia, so probably they did something during their lives that other people thought it was worthy, but then usually the cities are different, so all these people moved, and here in the US maybe we have a lot of cities that are attracting these people to do this exciting research. Most of my co-authors, I think, are almost all foreign. How about you?
Yeah, same thing. Yeah. It's actually an interesting time in the history of science, in the history in the United States, but anywhere, where, I think what we see now in the United States at this time in history was true of Europe, before the Second World War in certain places. And so you see that. And actually, there's very interesting writings about, places that sort of have a special feel, a certain zeitgeist for new things getting done. There's a beautiful book by Peter Hall about, it's actually about cities unavoidably, but it's about sort of golden ages. Why is it that certain places have certain golden ages? And they have to do with the sort of this tension of something being possible, but also of people wanting to come there to do it. And so those places, they may happen to be in a country at a certain point in time, but what they do have is that universal character, that people that want to do a certain thing tend to flock together and converge together to create that. And so the places where that's institutionally possible, tend to have that magic going on for it. And, you have to look for it if that's your mission.
What's next for Luis Bettencourt? Are you going to continue on cities? Are you going to continue exploring science?
I intend to do all this. I'm also working a lot on human cognition, trying to understand, systems neuroscience and how we perceive the world. These are obviously too many things to do at once, but I think they are complementary and they give you different points of view on complicated problems. Sort of my approach, which I'm not recommending to anyone, is that when you take a really hard problem like looking at cities, hard in the sense of being messy, you have to see it from lots of different points of view until you find sort of the ways in. And I think and it's obvious that, a lot of people in economics and sociology and many other traditional disciplines looked at cities, but that was not enough to kind of specify the fullness of the problem without mangling it. So to me, I try to find combinations of problems that I think on the one hand are exciting to me and they're on the verge of change because there's data, because there are new methods, etc. But also that come together in ways that both make me happy, but also, I think, inform other aspects of other problems I'm interested in. So I'll be working on cities, I'm sure, for a long time, as well as sort of human creativity and where that comes from and where that goes. So
that's wonderful. Thank you very much, Luis, for sharing all these wonderful things with us.
Yeah.
Thank you.
My pleasure, Cesar.